Hi, this is Jessica Maika Quijano, and in this video, I will answer a few problems from different topics in physics and try to briefly explain those topics. So here's the problem. Sean and Greg are on a job site standing on two beams 11 feet apart. They need to lift their crate of tools midway between them with ropes up 33.5 feet to where they are working. A. What is the angle between the ropes when the crate is on the ground? B. How much force do Sean and Greg need to exert on the ropes when lifting the 115-pound crate off the ground? C. How much force do both Sean and Greg need to exert when the crate is 5.75 feet below them? D. Explain why the force to lift the crate changes as it moves closer to them. So let us first sketch the problem. So we have Sean and Greg on two beams that are 11 feet apart, and they need to lift a crate midway between them that is 33.5 feet to where they are working. And so we are looking for the angle of the ropes. So a way for us to find the angle of this rope is to find these other angles. Since this crate is midway between them, so if we cut a line in the half, we create two equal right triangles. Therefore, this angle here is equal to this angle here. And since this is a right triangle, we can use trigonometric identities. So for this angle, we already have opposite, which is 33.5 feet, and its adjacent, which is half of 11, so 5.5 feet. So we can use tan theta is equal to opposite, 33.5 feet, over adjacent 5.5 feet. So our angle therefore is 80.68 degrees. So that is only for this angle. But since the internal angle of a triangle is 180 degrees, we can then have our angle as 180 minus 80.68 times 2, since these two are equal. So we have 18.64. So our angle therefore is 18.64. So for letter B, the question is the force when the crate is 115 pounds. So we have to draw a force diagram. So we have the first rope here, let's name that F1, and then another rope here, F2, and then the crate FW, which is equal to 115 pounds. Now for its angle, since this one here is 80.68, therefore the angle here is also 80.68, since these are two parallel lines and this rope is the diagonal line that cuts it. So this one and this one is equal. So we have 80.68 degrees, and since these two are equal, so 80.68 degrees. So we now have to set the sum of the x components into 0 and the y components into 0. So x component, then y component. So for this, the x component is 0, and its y component is negative 115, and it's downward. This one is positive F1 cos 80.68, since it's adjacent. It's positive since it's on the first quadrant. It's also positive F1 sine 80.68. It's y component. For this, we have negative F2 cos 80.68 and positive F2 sine 80.68. So we now have to set the sum of the x component into 0 and the y components into 0. So first, for the x component, we have 0 plus F1 cos 80.68 minus F2 cos 80.68 equals 0. So we have F1 cos 80.68. If we add F2 on both sides, so we have positive F2 cos 80.68. And since they both have cos 80.68, we can cancel that out. So we have F1 equals F2. So for the y component, we have negative 115 plus F1 sine 80.68 plus F2 sine 80.68 equals 0. And since F1 is equal to F2, therefore this value is equal to this value. So I'm going to use F1. So we have negative 115 plus 2F1 sine 80.68. Again, 2F1 because they're equal. And we have to add 115 on both sides. So we have 2F1 F1 sine 80.68 equals 115. Divide 2 sine 80.68 on both sides. So cancel. So we have F1 is equal to 115 over 2 sine 80.68. So our F1 is equal to 58.27 pounds. And since F1 is equal to F2, so F2 is also 58.27. So that is for letter B. Now for letter C, the question is when the crate is 5.75 feet below them. So basically, we have to do the same things, but with a different height, so a different angle. So again, we have the two beams that are 11 feet apart. And then the crate is now 5.75 feet below them. Again, we have to find this angle. And so again, tan theta is equal to 5.75 feet. And it's adjacent 5.5 feet. So our angle therefore is 46.27 degrees. So now let us draw a force diagram for the new situation. So we have F1 here with an angle of 46.27, F2 46.27, and the FW equal 115. So again, X component, and then Y component. You have 0 for this, and negative 115. Positive F1 cos 46.27, then positive F1 sine 46.27. This one is negative F2 cos 46.27 and positive F2 sine 46.27. Again, let's sum up into 0. Cos 46.27 minus F2 cos 46.27 equals 0. So again, we have F1 cos 46.27 equals F2 cos 46.27. So F1 is equal to F2. For the Y component, we have negative 115 plus F1 sine 46.27 plus F2 sine 46.27 equals 0. Again, equal. So we have negative 115 plus 2F1 sine 46.27 equals 0. So 2F1 sine 46.27 equals 115 over 2 sine 46.27. So F1 is equal to 2 sine 46.27. So we have F1 is equal to 79.57 pounds. And so is F2 since they are equal. So that is our answer for letter C. For letter D, explain why the force to lift the crate changes as it moves closer to them. So as we can see in our calculations, the value of the force depends on the angle. So when the angle theta becomes smaller, the value of the force becomes bigger compared to the first one. With a larger theta, we have a lesser force. And since the angle in here becomes smaller, therefore the angle here becomes bigger since the internal angle is 180. So when this becomes smaller, this becomes bigger. And so when the crate gets closer to them, it's heading towards a more horizontal line. So they're not just pulling upwards, but they're also pulling horizontally. So here's the problem. Louisa, whose mass is 45 kilograms, is standing at the end of a 5.50 meter diving board, which has a mass of 35.7 kilograms. A. What force must the bracket and fulcrum exert on the diving board? B. Where would Louisa stand to have both the fulcrum and the bracket apply an upward force? So first, let us draw our force diagram. So we have the diving board here, and then the bracket, and then the fulcrum. And so we have Louisa standing at the end with 45 kilograms. And then the board has 35.7 kilogram mass, and its center of mass is in its middle. So let's have it here, 35.7 kilograms. So for question A, we're looking for the force that the bracket and the fulcrum exert on the diving board. So let's name this FF, or force of the fulcrum, and then this FB. We're looking for the force they exert on the diving board. And so since this is just mass and not force, so let's have force equal mass times gravity. So let's name this F1 and this F2. So for F1, we have 35.7 kilograms times 9.81 meters per second squared. So the F1 is 350.22 newtons. And for the F2, we have 45 kilograms times 9.81 meters per second squared. So we have 441.45 newtons. So we have to set the sum of the opposing forces equal each other. So we have this 2 downwards and this 2 upwards needs to equal each other. Therefore, F1 plus F2 equals FF plus FB. And we also have to set the sum of the counterclockwise torques and the counterclockwise equal each other. And to do that, we have to set a point of rotation. So I'm gonna set this as the point of rotation. So let us have the clockwise first. So the only clockwise here are these two. It is clockwise. So we have the formula for torque is force times the distance. So the force for F1 is 350.22 newtons. Its distance is 2.75 meters. So 2.75 meters plus the F2, we have 441.45 newtons times its distance, which is 5.50 meters. So we have 5.50 meters. So therefore it is 3,391.08 Newton meter. So that is the clockwise. So for the counterclockwise, we only have this as our counterclockwise since this is our point of rotation. So we have FF times its distance is 1.53 meters. So we have FF times 1.53 meters. So we have to set the two equal each other. So we have 3391.08 Newton meter equals FF times 1.53 meters. So FF therefore is equal to 3391.08 Newton meter over 1.53 meters. So cancel the meters. So we have FF therefore is equal to 2,216 over a 0.39 newtons. So that is one of the required values. So to find the FB, we have to go back to this equation. Since we have the value F1, F2, and FF, we can find the FB. So FB therefore is equal to F1 plus F2 minus FF. So we have F1 350.22 newtons plus 441.45 newtons minus 2216.39 newtons. So our FB is negative 1424.72 newtons. Now this negative sign only indicates that the bracket exerts force that is downward, so it pulls down on the diving board and not exert force upward. So for question B, where would Louisa stand to have both the fulcrum and the bracket apply an upward force? Now, the fulcrum already applies an upward force, and the bracket is downward since it's negative. So to make it upward, we have to make this a positive value. Now, the main reason why FB is negative is because the value of FF is greater than the value of F1 plus F2. So therefore, for us to make FB a positive value, we have to lower the value of FF and let it be less than the value of this. So since F1 plus F2 is 791.67, we have to reduce the value of FF to less than 791.67. And as we can see in here, the FF depends on the value of the clockwise torque, since we have here 3,391. So to reduce the value of FF, we have to reduce the value of the clockwise torques. And so for us to reduce the value, we have to move Louisa farther back so that this torque will have a lesser value. So let's say our FF should be 790 so that it's less than 791.67. So if we have a 790 FF, so our value for the clockwise torques should be 1208.7. So if we have this 1208.7 value for the clockwise torques, well, let's find the distance Louisa should have. So let's subtract 350.22 times 2.75. So we have that divided by 441.45. So we have 0.55 or 56 meters. So therefore, Louisa has to be 0.55 meters, and that is roughly in this area. So therefore, that is between the fulcrum and the bracket. So for us to have both the fulcrum and the bracket apply an upward force, Louisa has to stand between the fulcrum and the bracket. Here's the problem. Rosita needs to purchase a sump pump for her basement. A. If the pump must carry 10 kilograms of water to a height of 2.75 meters each minute, what minimum wattage pump is needed? And B. What three main factors determine power for a sump pump? So let us first list down all the given data. So we have mass of the water, which is 10 kilograms. And then we have the height, or our displacement, which is 2.75 meters. And then the time, it says it's each minute, so that's 1 minute. So 1 minute equal to 60 seconds. So the question is, what minimum wattage? So watt is the unit of power, so we're looking for the power. And the formula for power is work over time. But we don't have the value of work, but work is equal to force times the displacement. So let's substitute that here. So we have force times displacement over time. We also don't have force, but we have the mass, and force is equal to mass times gravity. Therefore, let's substitute mg here for F. So let's have mgs over t. Let's now solve for our power. So m is 10 kilograms times s, which is 2.75 meters. Oh, the g is 9.81 meters per second squared. And we have t, which is 60 seconds. So 10 times 2.75 times 9.81 cross divided by 60. So we have 4.5. Let's have it as 4.5 watts, since kilograms times meters per second squared is Newton, and this is meter over second, and this is equal to watts. So we have 4.5 watts. So our P is 4.5 watts. Now the second question is, what three main factors determine power for a sump pump? Now based on our formula for power in here, the three main factors is the mass, the distance, and the time. Since G is constant, so the only factors that can affect the power is the mass of the water, the distance the water is being carried, and the time it takes for the water to move. A roller coaster designer must carefully balance the desire for excitement and the need for safety. The most recent design is shown in Figure 8.20. A. If a 355 kilogram roller coaster car has zero velocity on the top of the first hill, determine its potential energy. B. What is the velocity of the roller coaster car at the specified locations in the design? C. Explain the relationship between velocity and the position on the track throughout the ride. Consider the track to be frictionless. Okay, for the question A, we have the data of the mass of the roller coaster car, which is 355 kilogram. Then at the top of the first hill, its velocity is 0. And based on the figure, we have the height of 60 meters. So the question is the potential energy. So the formula for potential energy is mass times gravity times height. So we substitute 355 kilogram times 9.81 meters per second squared times 60 meters. So the potential energy is 208,953. This is Newton times meter. Or in scientific notation, we have 2.09 times 10 raised to 1.3455 joules, since Newton meter is also equal to joules. So the potential energy is 2.09 times 10 raised to 5 joules. So for the question B, which is the velocity of the roller coaster car at the specified locations, we have to consider the fact that the sum of the potential and kinetic energy is constant throughout the ride. So since we already have the potential energy on this point, and we also have its velocity, so now we can find that constant of the sum of potential and kinetic energy, which is also the same for all the points in the ride. So we have EP plus EK equals to mgh plus 1/2 mv squared. Since we already have the EP on this point, which is 2.09 times 10 raised to 5 joules, so its kinetic energy is 1/2 times mass, 155 kilogram, times V is 0, so therefore we can cancel this out. So the sum of the potential and kinetic energy for all the points is equal to 2.09 times 10 raised to 5 joules. Now to find the velocity, we have to use this formula. So we have mgh plus 1/2 mv squared is equal to that. So V therefore is equal to 2.09 times 10 raised to 5 joules. Subtract mgh, divide m, and then multiply by 2. And then the square root. So square root of 2 times 2.09 times 10 raised to 5 joules minus mgh over m. So that is our formula for V. So for point A, which has a height of 0, our velocity is equal to 2 times 2.09 times 10 raised to 5 joules minus 355 times 9.81 times 0 over 355. So we can cancel this out since it's 0. So V is equal to 2 times 2.09 10 raised to 5 355. So we have 34.31 meters per second. So we have the unit is in joules over kilogram, as you can see, since joules is equal to Newton meter over kilogram, and Newton is equal to kilogram meter second squared times meter over kilogram. So we cancel this out. We have square root of m squared over s squared, so therefore that is m over s. So meter per second for the velocity. So for letter B, we have a height of 20 with the same formula. 2 times 20 meters for 355. So V is equal to, let's put that all in the calculator. So the answer is 28.02, again, meters per second. So for letter C, which has the height of 30 meters, so basically that's the same formula, and I've already put up everything in the calculator. So let's just put it indirectly in the calculator, times 30. So therefore V is equal to 24.27 meters per second. For point D, we have a height of 40 meters. So H is equal to 40 meters. So V, is equal to 19.82 meters per second. That is the velocity. For question C, explain the relationship between velocity and the position on the track throughout the ride. So as we can see on our results, as the elevation gets higher, 40, the velocity gets lower. So we have 0 height, 34.31 velocity. With 20, it's now 28. And for 30, it's 24. And for 40, it's 19.82. So the higher the elevation, the lesser is the velocity. Water wheels are used to convert kinetic energy from falling water into useful mechanical energy. A. If an average of 10 kilograms of water flows onto a water wheel every second, how much torque does the water exert on a water wheel of radius 2.45 meters? B. The torque exerted by the water causes the wheel to move with an angular acceleration of 0.593 rad per second squared. Using this information, find the rotational inertia of the water wheel. C. If you were the designer of this water wheel, what are 2 things you could do to increase the rotational inertia of the water wheel? So for the question in A, we are given the data of the mass of the water, which is 10 kilograms, and then the radius of the water wheel, which is 2.45 meters. So the question is the torque. And torque is equal to force times the distance. So we don't have force, but we have mass, and since force is equal to mass times gravity, so we have that, and ST is equal to the radius, since the axis of rotation is from the middle of the water wheel. So let's substitute 10 kilograms times 9.81 meters per second squared times 2.45 meters. So the torque is 240.35. That's Newton then meter. So torque is 240.35 Newton meters. So for letter B, the question is the rotational inertia. So with this torque, we are given the angular acceleration of 0.593 rad per second squared. So torque is equal to the rotational inertia times angular acceleration. So therefore, rotational inertia is equal to torque over angular acceleration. So let's substitute 240.35 Newton meter over 0.593 rad second squared. So we have 405.30. So for our unit, we have, so Newton is kilogram meter per second squared, and then meter we have 1 over second squared. So we cancel this and cancel that. So we have kilogram times meter squared. So that is our rotational inertia. So for question C, if you were the designer of this water wheel, what are two things you could do to increase the rotational inertia of the water wheel? So to increase the rotational inertia, we could increase the torque. And to increase the torque, since torque is force times the distance, we can increase the distance or the radius of the water wheel. We could also increase the force or the mass if that is possible, which is unlikely. But another thing that we can do is to make the water wheel a ring rather than a flat, solid disc, because a hollow water wheel means that the mass would be concentrated towards or farther away from the center of the water wheel, and this will cause the rotational inertia to increase. A hairpin turn on a concrete racetrack has a radius of 117 feet. A. Since the frictional force between the road and the tires acts as a centripetal force, find the vehicle's maximum possible speed around the turn. The coefficient of starting friction between rubber and concrete is 2. B. What would be the maximum velocity around the next turn if it has double the radius of the first turn? C. Explain how the radius of a turn influences the centripetal force and the maximum velocity for a vehicle. So our given data for question A is the radius of the racetrack, which is 117 feet, and we have a coefficient of the friction, which is 2. And since the centripetal force is equal to the frictional force, and frictional force, as we recall, is equal to the coefficient times the normal force. Therefore, force is equal to the coefficient, which is 2, times the normal force, which is mg. So we don't have a value for m, so I'm going to leave f like that. Since f is mv squared over r, and we are looking for the v, so v is equal to f times r over m, the square root of f r over n. So let's substitute. F is 2 mg times r over m. So as you can see, m can be cancelled out. Therefore, we didn't really need the value of m. So therefore, the mass doesn't really affect the velocity of the vehicle. So square root of 2 times gravity in US unit is 32.2 feet per second squared times our r is 117 feet. So V is equal to 86.80 feet per second. So that is our V. For letter B, the question is still the maximum velocity, but the radius is doubled. So we have and R, which is equal to 117 feet times 2. So R is equal to 234 feet. So still with this formula here, V is equal to square root of 2 times gravity, 32.2 feet per second squared, times our new radius, which is 234 feet. So V is equal to 122.76 feet per second. So that is our velocity. Now for letter C, explain how the radius of a turn influences the centripetal force and the maximum velocity for a vehicle. So based on our results in A and B, when the radius is increased, the velocity also increases. But based on this formula, for the force, when the radius is increased, since it is in the denominator, therefore it is inversely proportional to the force. So when the radius is increased, the force reduces. But for its velocity, when the radius increases, the velocity also increases. How much power does a motorcycle need to produce 72 foot-pounds of torque while the engine crankshaft rotates at 3,000 revolutions per minute? B. When shifted into a higher gear, the same amount of power rotates the engine crankshaft at 5,000 RPM. How much torque does the engine produce in this higher gear? C. Using your knowledge of power, torque, and angular speed, explain why a motorcycle should be in a low gear when climbing a steep hill. So for A, our given data is the torque, which is 72 foot-pound, and then the angular speed of 3,000 RPM, and the question is the power. So the formula for power is torque times angular speed. But since it is in US unit of measure, we have to multiply it to 0.105 minute over rev second. So power therefore is 72 foot-pound times 3,000 revolutions per minute times 0.105 minute over rev second. 72 times. So we have the power is 22,680. Cancel that. So foot-pound per second. That is our power for letter A. So for B, with the same amount of power, but in a higher gear, we have the angular velocity of 5,000 RPM. So the question is the torque. So with this formula, we can manipulate it into torque is equal to power over angular speed times 0.105 minute over rev second. So torque is equal to 22,680 foot-pound per second over 5,000 revolutions per minute times 0.105 minute over rev second. So torque is 43.2. Now cancel. So we have cancel foot-pound. So that is our torque for letter B. So the question in C is, using your knowledge in power, torque, and angular speed, explain why a motorcycle should be in a low gear when climbing a steep hill. So to climb a steep hill, we require more torque. And as we can see in our results here, the higher the gear, the higher also is the velocity, but the lower is the torque compared to the one with the lower gear with higher speed. Lower speed but higher torque. So we need lower gear to have a higher torque. So here's the problem. A wheelbarrow 6 feet long is used to haul a 180-pound load. A. How far from the wheel is the load placed so that a person can lift the load with a force of 45 pounds? Find the MA. So let's list all the given data. So we have the effort arm, which is 6 feet long, and then the resistant force, which is 180 pounds, and the effort force, which is 45 pounds. So the question is the resistance arm. So according to the law of simple machines, Fr times Sr is equal to Fe times Se. So Sr is equal to Fe times Se over Fr. So let's now substitute. 45 pounds times 6 feet over 180 pounds. So our answer is 1.5 feet, since we cancel the pounds. So SR is 1.5 feet. Now for letter B, find the MA. The formula for MA, or mechanical advantage, is the effort arm over the resistant arm. So we have 6 feet and the SR, which is 1.5 feet. So the MA is 4. So here's the problem. A snowblower auger has a radius of 7.75 inch and a pitch of 6.80 inch. A. What is the mechanical advantage of this auger system? B. How much effort force is needed for the auger to throw 23.4 pounds of snow? And C. What happens to the mechanical advantage if the pitch is reduced? So the given data are the radius, which is 7.75 inch, the pitch, which is 6.80 inch. So we're looking for the mechanical advantage. The formula for mechanical advantage is 2 pi r over pitch. So 2 pi r, which is 7.75 inch, and the pitch is 6.80 inch. So let's calculate. So our answer is 7.16. So the mechanical advantage is 7.16. Now, letter B. How much effort force is needed for the auger to throw 23.4 pounds of snow? So since MA is also equal to FR, or the resistance force over the effort force. Now we are given the resistance force of 23.4 pounds. So let's substitute that. We're looking for the FE. So therefore it's FE is equal to FR over MA. So it's 23.4 pounds over 7.16. So our FE is equal to 3.27 pounds. So the FE is equal to 3.27 pounds. The last question, what happens to the mechanical advantage if the pitch is reduced? Now, according to this formula, we can see that the pitch is inversely proportional to MA because it's in the denominator. Therefore, if the pitch is reduced, then the MA would increase. Here's the problem. Find the mechanical advantage of the compound machine shown in figure 10.25. The radius of the crank is 1 feet and the radius of the axle is 0.500 feet. So as we can see in the figure, we have 3 simple machines. We have the inclined plane, the pulley, and the wheel and axle. So let us first find the mechanical advantage of the inclined plane. So the formula is length over height. So our length here is 50 feet and height is 10. So 50 over 10 is 5. Now for the pulley, since we have one continuous cord, we can just count the number of strands. So we have 1, 2, 3, 4. So the MA for pulley is 4. Now for the wheel and axle, we have the given data here. So our formula is the radius of the effort and the radius of the resistance force. So we have the effort is the crank, so we have 1.00 feet over 0.5 feet. So therefore that is 2. So the mechanical advantage of the compound machine is to multiply all these MA. So we have 5 times 4 times 2 is equal to 40. So our answer is 40. Here's the problem. Instead of carrying a full-size tire, many automobiles are equipped with a significantly smaller spare tire with a warning that the car should not exceed a speed of 50 miles per hour. A. How much pressure does the smaller tire withstand if it must support 1/4 of a 1,650 kilogram minivan and its area of contact with the road measures 8.26 centimeters by 15.9 centimeters? B. Find the pressure on a full-size spare tire if its area of contact with the road measures 15.2 centimeters by 21 centimeters. C. Why is it important to limit the speed of the smaller spare tire? And the given data is the mass of the minivan, which is 1,650 kilogram. But since a tire only supports 1/4 that, so let's multiply it by 1/4. So the mass is therefore 412.5. Now for the letter A, the area of contact for the smaller tire, let's in that S, is 8.26 centimeters by 15.9 centimeters. So that is 131.334 square centimeters. But since the unit for pressure or stress is usually in Newton per meter square meter, so let's multiply that by 1 meter is 100 centimeters. It's squared. So basically that's 10,000. So that's 4 decimal places. So 1, 2, 3, 4. So we have 0.013. Let's stop that. Meter squared. So that is the area for the small tire. So the question was the pressure. So the pressure or the stress is equal to force over area. So the force is not yet given, but there's a mass, and since force is equal to mass times gravity, so force is equal to 412.5 times 9.81 meters per second squared. So we have 4,046.625 newtons. So let's substitute that. So 4,046.625 newtons over the area, which is 0.013 meter squared. So the answer is 311,278.8462 Newton per meter squared, or in scientific notation we have 3.11 times 10 raised to 5 Newton per meter squared. So that is for the smaller tire. Now for the letter B, which is the bigger tire, we now have a new area, the bigger tire, which is 15.2 centimeters by 21 centimeters. So that is 319.2 centimeters square. Again, let's convert into meters. So that is 0.032. Let's round it up to 2. So since we still have the same force, since it's the same car, so let's substitute that. 4,046.625 over 0.032 square meters. So we have 404. That is 1, 2, 6, 4, 5, 7, 0, 3 Newton per meter squared, or 1.27 times 1, 2, 3, 4, 5, 10 raised to 5 Newton per meter squared. So that is for the bigger tire. Now see, why is it important to limit the speed of the smaller spare tire? So basically, driving with high speed on a high pressure tire increases the heat energy in the tire that could break down the tire, resulting in a blowout. So every morning, Shakira weighs herself on a bathroom spring scale. Today, the scale reads 134 pounds. A. If the spring in the bathroom scale compresses 0.752 inches, find its spring constant. B. If her husband steps on the scale and the spring compresses 1.13 inch, how much does he weigh? C. Why is there a limit to how much weight a spring scale can measure? So for A, the given data is Shakira's weight or force, which is 134 pounds. And then the change of length in the spring scale is 0.752 inches. Then we have to find the spring constant, which is letter K. And the spring constant is equal to force over change in length. So let's substitute 134 pounds over 0.752 inches. The answer is 178.19 pound per inch. So that is our K, the spring constant. Now for B, if her husband steps on the scale and the spring compresses 1.13 inches, how much does he weigh? So we have a new change in length, which is 1.13 inch. And so since it has the same spring constant, since it is the same spring scale, so K basically means that the ratio for force per change of length is always the same. So meaning we still have the same value for K, which is 178.19 pound per inches. So we're looking for the force or the weight. So with the formula K equals F over change in L, F is therefore K times change in L. So K is 178.19 pound per inch times 1.13 inch. So you can cancel the inch. So the answer is 201.36 pounds. So that is the weight of the husband. Now for letter C, why is there a limit to how much weight a spring scale can measure? It has a limit because there will be a point where the spring could no longer be able to compress. Raul weighs 235 pounds and is able to float in seawater but not in fresh water. Find his volume assuming that his density is the average density of seawater and fresh water. So the data given are Raul's weight, which is 235 pounds, and his density is the average of the density of seawater and fresh water. So the density of seawater is 64 pounds per cubic feet, and the density of fresh water is 62.4 pound per cubic feet. So his density is the average of the two. So 64.0 pound per cubic feet plus 62.4 pound per cubic feet over 2. 64 plus 62.4 divided by 2. So the answer is 63.2 pound per cubic feet. So that is his density. But the question is his volume. So since the formula for density is the weight over volume, therefore volume is equal to the weight over the density. So his weight is 235 pounds over the density, which is 63.2 pound per cubic feet. So the volume is 3.72 cubic feet. Cancel the pounds. So that is the answer. A crane can lift a maximum of 9,000 newtons in preparing to lift and move an underwater concrete mooring. The 1.25 meter by 1.25 meter by 0.450 meter concrete block is located in seawater. Verify that the crane is strong enough to lift the mooring by finding A. its volume, B. its dry dock weight, C. the water's buoyant force, and D. the force needed to lift the mooring while it is underwater. So for A, which is the volume, we are already given the dimensions, which is 1.25 meter by 1.25 meter by 0.450 meters. So our volume is 0.703, let's go with that, cubic meters. So that is our volume. So for B, we have to find its dry dock weight. So weight is equal to mass times gravity. So we therefore have to find the mass. And mass is equal to the density times the volume. So since this is a concrete mooring and it is in the dry dock, so the density of concrete is equal to 2,300 kilogram per cubic meter, and our volume, which is 0.703 cubic meter. So our mass is 1,617.19 kilograms. Cancel the cubic meters, so that is our mass. So our weight therefore is equal to 1,617.19 kilograms times our gravity, which is 9.81 meters per second squared. So we have 15,864.61 newtons. So that is our weight in dry dock. So for C, we have to find the water's buoyant force. And since the buoyant force is equal to the weight of the displaced water, so we have to find the weight of the displaced water. So again, the weight is equal to mass times gravity. So our mass is density times volume. And since we are dealing with the displaced water and the water is seawater, so the density of seawater is 1025 kilogram per cubic meter. And again, our volume 0.703 cubic meter. So our mass is equal to 720.58 kilograms. So our weight therefore is 720.58 kilograms times 9.81 meters per second squared. So we have 7,068.84 newtons. So that is our buoyant force. So for letter D, we have to find the force needed to lift the mooring while it is underwater. So the force needed to lift is equal to its weight in the seawater. So the weight in seawater is equal to the weight in dry dock minus its buoyant force. So therefore, weight in dry dock is 15,864.61 newtons minus the buoyant force, which is 7,068.84 newtons. So the weight in seawater is 15,864.61 minus 7,068.84. So we have 8,795.77 newtons. So now we can verify that the crane is strong enough, since the weight in seawater is only 8,795.77 newton, and the crane can lift a maximum of 9,000. So yeah. A flexible hose with inside radius 0.250 inch leads to a shower fixture with 15 holes, each with radius 3.13 times 10 raised to negative 2 inch. A. If a faucet is opened to allow the water to move through the pipes at 3.94 feet per second, what is the speed of the water as it comes out of the holes? B. What are two ways to increase the speed of the water from a shower fixture without opening the faucet further? So for A, we are given the radius of the flexible hose. We'll have that as R1 is 0.250 inch, and then the radius of the holes R2, which is 3.13 times 10 raised to negative 2 inch. So since we already have the radius, we can find its cross-sectional area, which is a circle. So area is equal to pi r squared. So for A1, we have pi times 0.250 inch squared. So 0.250 squared. So we have 0.196 inch squared for A1. And for A2, pi r squared. But since we have 15 holes, so we have to multiply it by 15. So pi times 3.13 times 10 raised to negative 2 inch squared times 15. So we have 0.046 inches squared. So that is A2. We are also given the velocity as it moves through the pipes, or the V1, which is 3.94 feet per second. And since our area is both in inches, so let's convert this to inch. Cancel the feet. So we have the V1 is 3.94 times 12 is 47.28 inches per second. So that is V1. So the question is the speed of the water as it comes out of the holes, or the V2. So we have to consider the fact that Q, or the flow rate, is constant throughout the pipe. And since Q is equal to A times V, so A1 times V1 is equal to A2 times V2, since it is constant throughout the pipe. So we have A1 times V1 equals A2 times V2. So V2 is equal to A1 V1 over A2. So A1 is 0.196 inch squared times V1 is 47.28 inches per second over A2, 0.046 inches squared. So we have 0.96 times 47.28 over 0.046. So the answer is 201.45. To cancel this, so inches per second. So that is our V2, the velocity as it comes out of the holes. So for the question in B, what are two ways to increase the speed of the water from a shower fixture without opening the faucet further? So basically the question is how to increase the speed as it comes out of the faucet of the fixture. So the V2, how we can increase the V2. So with this formula, we can say that we have to increase the V2 without ever opening the faucet. And since A1 and V1 are both concerned with the faucet, so we can't do anything with A1 and V1. So the only thing that we can do is to reduce the A2, since A2 is in the denominator, therefore it is inversely proportional to V2. So to reduce A2, since A2 is equal to pi r squared times the number of holes, to reduce the A2, we can reduce the radius or we can reduce the number of holes. So if the area is reduced, so the velocity will become faster. The distance between New York City and London is 3,470 miles. A. If a radio wave from New York City is transmitted directly across the ocean, how long will it take to reach a receiver in London? B. In fact, due to the curvature of the Earth, radio waves cannot be transmitted directly across such large distances on the Earth. Instead, a signal is typically transmitted to a communication satellite located 2.20 times 10 raised to 4 miles above the surface of the Earth. If the satellite is located midway between the two cities, how long will the radio wave take to reach London? Disregard the effect of the curvature has on the calculation. So, for the first question, we have the distance between the two cities, 3,470 miles. And we are looking for the time it takes to reach the two cities. So, we have a formula of S times CT, where C is the speed of light, or 186,000 miles per second, since a radio wave is a electromagnetic radiation, and any form of electromagnetic radiation travels through the speed of light. So to find the T, we have S over C. So S is 3,470 miles over 186,000 miles per second. So we have 0.0187 seconds. You cancel out the miles. So the time it takes is 0.0187 seconds. Now for letter B, we now have a satellite located midway between them. So I'm going to sketch first. This is New York. This is London. And we have a satellite midway between them. And since they are 3,470 miles apart, therefore midway between them is 1,735 miles. So this is also 1,735 miles. And the satellite sits 2.20 times 10 raised to 4 miles above the Earth. So the radio wave has to go from New York to the satellite and satellite to New York. So as we can see, we have formed two right triangles. So the distance from the New York to the satellite is the hypotenuse of this right triangle, and it is equal to the hypotenuse of this right triangle. Therefore, to find the distance, we have to add the distance of this to this, which is the same. So we can use the Pythagorean theorem to find the value of this hypotenuse and then multiply it by 2 since these are the same distance. So S therefore is 2.20 times 10 raised to 4 miles squared plus 1,735 miles squared, then multiply thing times 2. So we have 2.20 times 10 raised to 4 squared plus 1,735 squared. We have 22,068 times 2. So we have the S is 44,136.62 miles. So now we can find the time. Again, time is equal to S over C. So time is 44,136.62 miles over C is 186,000 miles per second. Cancel the miles, so we have divided by 186,000. So the answer is 0.237 seconds. Find the intensity of two identical light sources located 0.880 meters and 1.12 meters from a point where the illumination is 5.86 lumen per meter squared. So we are given the distance of the two light sources, R1, 0.880 meters, R2, 1.12 meters, and these two light sources produce an illumination of 5.86 lumen per meter squared. So we're looking for the intensity of the light sources since they are identical, so they have the same intensity. So we have a formula for the illumination, which is I over 4 pi distance squared. But since there are two light sources that cause this illumination, we have to add the two light sources. So this is for the R1 and this is for the R2. So to find I, we have to add the two, 4 pi R1 squared, 4 pi R2 squared, that is their LCD. And so we multiply plus 1i times 4 pi 1 squared, that is E. So cross multiply 4 pi r1 squared times 4 pi r2 squared equals, factor out I, so we have 4 pi r2 squared plus 4 pi r1 squared. So therefore I is equal to E times 4 pi r1 squared times 4 pi r2 squared over 4 pi r2 squared plus 4 pi r1 squared. So since these numbers are recurring, I will find its values first. So for the R2, 4 pi R1 squared, so we have 4 pi R1 is 0.880 squared, so we have 9.73. Now for the 4 pi R2 squared, we have 12, 15.76. That is in meters squared, meters squared. So let us now substitute. E is 5.86 lumen per meter squared times 9.73 meters squared, then 15.76 meters squared over 15.76 meters squared plus 9.73 meters squared. So the answer is 5.86 times 9.73 times 15.76 plus 9.73 is equal to 35.25 lumen, since you can cancel this out, then cancel this, so we have 35.25 lumen as our intensity. Tamara uses a concave mirror when applying makeup. A. The mirror has a radius of curvature of 38 centimeters. What is the focal length of the mirror? B. Tamara's face is located 12.5 centimeters from the mirror. Where will her image appear? C. Will the image be upright or inverted? D. How long will her face appear to be in the mirror if her face is actually 25 centimeters long? So for the first question, we have the radius of curvature, which is 38 centimeters, and we're looking for the focal length. And the focal length is simply radius over 2. So we have the focal length of 38 divided by 2 equals 19 centimeters. So that is for the first question. So for B, Tamara's face is located 12.5 centimeters from the mirror. So SO equals 12.5 centimeters. So what will SI be? So we have a formula of 1 over F equals to 1 over SO plus 1 over SI. So 1 over SI will be 1 over F minus 1 over SO. So therefore we have 1 over SI equals 1 over 19 centimeters minus 1 over SO is 12.5 centimeters. So 1 over I will be 1 over 19 minus 1 over 12.5. So that is that. So we have to find 1 over, we have SI equals negative 36.54 centimeters. So that will be our SI. So for the third question, will the image be upright or inverted? Well, to know the image if upright or inverted, we have to find the magnification. Since a positive magnification means it is upright and a negative magnification means it is inverted. So the formula for magnification is negative SI over SO. So we already have an SI of Negative 36.54 centimeters over SO is 12.5 centimeters. So we have negative divided by 12.5. So we have 2.92. That is our magnification. And since it is positive, therefore the image is upright. Now for letter D, how long will her face appear to be in the mirror if her face is actually 25 centimeters long? So M is also equal to HI over HO. And since her face is 25 centimeters long, so HO is equal to 25 centimeters. So we have to find the HI since we already have the M. So HI therefore is equal to M times HO. So we have 92 times 25 centimeters. So our HI is equal to 73.08 centimeters. A fish tank made of crown glass is full of fresh water. A. What is the angle of refraction when the light travels from the air and enters the crown glass at an incident angle of 30 degrees? B. Determine the angle of refraction when the light leaves the crown glass and enters the water. C. If the aquarium is full of salt water, will the angle of refraction be greater or less than the angle of refraction for fresh water? So for the first question, we have an angle of incidence which is 30 degrees. And the index of refraction for the crown glass is 1.575. So we're looking for the angle of refraction. So we have a formula of N equals sine I over sine R. So sine R is equal to sine I over N. So we have sine 30 over 1.575. Sine 30 divided by 1.575. So we have the angle. So the R is equal to 18.51 degrees. So for the second question, it's now enters the water. So we have same angle of 30 degrees. And then the N for water is 1.33. So what is the R? Again, sine R is equal to sine I over N. So sine 30 over 1.33. So we have sine 30 divided by 1.33. So we have that. So the angle is 22.08 degrees. So for the third question, if the aquarium is full of salt water, will the angle of refraction be greater or less than the angle of refraction for fresh water? So the angle will be smaller because light refracts towards the normal line when entering a denser medium, since salt water is denser than fresh water.